Dear friends, myself Shailendra Kumar Gupta, Research Scholar Physics, DBS PG College, Kanpur, under the supervision of Professor Pragya Agrawal, Head Department of Physics, DBS College, Kanpur. That is a special series for CSI Net Physical Science, a special topic that is Operational Amplifier, Unit number 6. Now deliver the lecture number 4. In last lectures, we are discussed to start the properties of the operational amplifier. Today we discuss a special property of the operational amplifier, that is a CMR. CMR is very important properties. Means to that full form is common mode reduction ratio. Every universities, every competitive examinations, also as well as academic as well as a competitive exam, that is a very much favorite topic, that is the same common mode rejection ratio. That is also a very important property for operational amplifier. When we will discuss the linear integrated circuit, this is the most important linear integrated circuit, that is operational amplifier 741. 741 IC. So CMR means to common mode rejection ratio is defined as the ratio of the AD to AC. AD, what is AD? AD means to differential gain. And what is the meaning of ACM? That is a common mode gain. So, common mode rejection ratio is the ratio of differential mode gain to the common mode gain. Means to voltage gain, not taking the current gain. ADA D is a differential mode gain and ACM is a common mode gain. And if it is defined into the decibel, means to it is a decibel, so 20 log base 10 80 upon AC dB. dB means to decibel. You very well know that what is a decibel. Decibel is a unit of sound, and that CMR also is measured in unit of sound, that is a dB. dB बोले तो decibel. Decibel means to आपका bell, and that is multiplied by 10, that is a decibel. ठीक है, bell is a gram bell, which we will discover the आपका decibel. So after the, that is a decibel, that is unit of sound. So here, that is a common mode rejection ratio. Common mode rejection ratio is can be defined as ratio of differential voltage gain or to the, that is the common mode voltage gain. So that is a CMR means to common mode rejection ratio. AD means to differential mode gain to common mode gain. C common mode gain. So CMR, if you are defining dB, means to that CMRR आपका dB decibel. dB means to deci आपका bell. Clear है? Now we are discussing next slides. What is the meaning of differential? Differential mode means to that you are seeing that operational amplifier. That terminal is a non-inverting terminal. Non-inverting terminal. That is a inverting terminal. Inverting terminal. Terminal. So V1 is your non-inverting terminal voltage and V2 is your inverting terminal voltage. So that is a VD is a difference of both. That means to that is called differential mode. That is a differential. That is a differential mode input. Differential mode. Differential mode input. Okay. If that input is applied to this to the that terminal means to that VD means difference of both terminal voltage is applied as a input. That is a VD. VD if our VD is applied, then output becomes that gain is becomes AD, and so the output voltage. So the output voltage is your V out becomes आपका AD into VD. So that is a AD is a gain, differential mode gain. क्या हो? That is a differential mode gain. And VD is your very well known differential input voltage. Clear? That is a differential input voltage. And that is a output in this condition is AD into VD. Means to what is meaning of differential port? Means to different voltage are applied at operational amplifier terminal. Means to non-inverting terminal voltage is V1 and inverting terminal voltage is V2. So VD is applied at that terminal. In this condition, operation amplifier will be gives the output 1. That is AD into VD. Means now we define the very important quantity that is AD. Why we discuss the AD? Because the CMR is the ratio of AD to AC. Differential mode gain to the common mode. That is the meaning of differential mode gain. So what is the meaning of differential mode gain? So differential mode gain becomes AD, AD becomes AD becomes आपका V out 1 and divide by आपका VD. And what is VD? So V out 1 divide by आपका V1 minus. Okay. Now very clear that what is AD. So discussing next slide what is a common. Common mode means to common voltage applied to the both terminal. Common voltage applied to the same voltage to both terminal. Means to input is common mode is defined VCM. CM for the common mode. The subscript used in this that is a CM for the common mode. Okay. VCM is that is a common mode input voltage. Okay, common mode input voltage. That is a VCM. Okay, in this figure you are delivering the VCM. Okay, now this is a you well know that is a 741 IC number and that is a your supply voltage VCC and this is a minus VEE voltage and that is your output. Okay, so this is simple inverting voltage and this is your non-inverting voltage and applied to the whenever go to the common mode This is your simple operation amplifier, and this structure is your just like a common mode. That structure that structure is called common mode. Okay, this is your common mode voltage. This is your common mode voltage applied to the that point. Take that voltage applied here. Okay, and this is your inverting non-inverting terminal, your non-inverting, and this is your inverting. Okay, this is your inverting voltage. Okay, and this is your non-inverting. Clear? So we applied the voltage to VCM. VCM used to आपका V1 plus V2 upon that voltage applied to that is called VCM. So in this condition you are getting the output voltage आपका VCM. ठीक है, let us change some color. We are discussing. Uh, we are taking some new color. Just I take a green color. Okay. This we are taking here. This is becomes आपका V out आपका into AC. So VCM is a common mode voltage and ACM is a common mode gain. Okay, so output 2 is becomes ACM into VCM. VCM is a common mode input voltage and ACM is a common mode voltage. So in this condition we are getting ACM. ACM, what is ACM? Is your output 2 and divide by VCM. And what is VCM? So that is your V out 2 आपका V1 plus V2 and this is and divide by आपका both factor by 2. So this is a common mode voltage gain. This is your common mode voltage gain. Okay. So that is a now we again comes on the first slide. First slide that is a what is a CM. So CMR is now you are well understand that the 80 upon ACM. ठीक है means to CMR is a ratio of differential mode gain to the common mode gain. If you are taking dB, if we are taking voltage, your dB becomes आपका so here some important point is understand that if you are taking a power in power case in your dB becomes आपका 10 uh, 10 10 log P out upon you are just P out upon P, okay, and that is take a base 10. If our that is a voltage, if our voltage then dB becomes 20 and log base 10 आपका you just V out upon V, that means to voltage. If we are taking the power, if we are taking a current, sorry, current, so dB becomes 20 log base 10 I out upon I in, I out upon I in. So, if you are taking power, there you are taking the power is 10 multiplied by 10. If you are taking voltage, that is taking 20. If you are the current, so it is 20. So that 80 is a voltage gain and ACM is a voltage gain. So it is multiplied by the 20. Okay, you are well understand what is the CMR. CMR means to common mode rejection ratio. It is also depend on the frequency. So we are discussing the some next lectures dependency on the frequency. Okay, so common mode rejection ratio is a very important property of the operation amplifier. Common mode rejection ratio taking many questions in all universities as well as academic as well as a competitive exam. So in all universities lectures will have to CMR. So it is a very important property of operation amplifier uh, to decide the matching between the terminal. Why we understand or discuss the CMMR and because it is so the matching between the terminals means to both terminal how to match to each other to deliver the final output. Now we discuss the what is output in this condition. So please see output final output is a sum of output 1. Output 1 means to uh, differential condition, differential differential condition and differential mode and output 2 in common mode condition. Common mode, and this is differential mode आपका differential mode and final output is though that is a VT into AT means to differential and ACM into VCM that is output 2. So final output of any operation amplifier is just a combination of the both output means to final output becomes Vout is equal to Vt into At plus Acm into Vcm. That is a final output. So the many numerical problems discussed in this condition and keep in mind that output voltage becomes a very important factor. So many questions are in competition uh, that are there are some theoretical question as well as some numerical question. Some questions are arises numerical and theoretical. So output voltage discussed in this condition in common mode condition. So very important questions are arises in this course. Theoretical question is mostly the both values are given the dB differential mode gain and common mode gain. So we adapt it. The result is finally we are getting. And some questions are having to differential mode gain in simple given and some quantity dB. So firstly convert into the one that is a dB both quantity matlab differential gain and the common mode gain in dB as well as you are discussing in the simple and simple if you are calculating the simple gain you are converting to dB or you are converting to dB to simple gain. So question are both conditions are realized. So discussing properly in some numerical session organized on these properties. So we are completing the in last lecture number 3 offset properties and now today we discuss the completing the discussion on the CMR. So in next lecture we are discussing the slew rate. So wait to the next lecture and very much thank you to taking and appreciating that class and if you passes to any problem you mail us to me and my supervisor, and also you will meet you at the Department of Physics, DBS College, Kanpur. Thank you very much.